Good afternoon, everybody. It is Wednesday, the 21st of September, and Lew is here with us. You've read his background on the announcements we've made. To save time, I'm just going to say Lew has been doing lots of work with Vielight, stuff with COVID research. As you've heard him here before, he's a real master at working with photobiomodulation. And today the focus will be on how it's effective with long COVID. Lew, thank you so much for being here. You're a busy man, and we know that. We appreciate your time. It's all yours.
Absolutely. Thank you for inviting me. I hope this is going to be beneficial, and let's get going. What I plan to do here, some of you have heard my presentation of COVID before, and that was on the previous study. Actually, we're waiting for regulatory clearance for that one, but we're not waiting. We are planning to do a long COVID study, which obviously forces me to do more research, and I'm going to share with you and why potentially photobiomodulation may work, and you can figure out how you might be able to use it in your practice. It's an ongoing thing. I'm pretty sure almost all of us know somebody or a client who might need help. So what I plan to do is this: we have pretty good information now on how we might be able to treat COVID, and I'll go through this very quickly, and how that's going to lead us to do new investigations into long COVID. And while waiting for this to be done, how maybe it may be helpful to you. So that involves new data, new interventional parameters, pretty different from what we've done before. Just a quick revision on how COVID has been attacking the human body. It starts with the upper respiratory tract, moves down to lower respiratory tract, and then it attacks your organs, and then you get all kinds of problems like the cytokine storm. And it has actually quite a lot of implications on long COVID. And now that we are in the Omicron phase, this is actually what was happening with the Delta variants. Pretty fatal, pretty profound. But the Omicron is mainly in the upper respiratory area, so you don't get the kind of fatal outcomes like particularly the Delta. But we are still dealing with long COVID, and they are numbering in millions out there. I think it's receding after, but it's sporadic, and particularly when you have brain fog, it seems to last longer than some of the other symptoms. But let's quickly go through. Now, the first phase was, and as the virus enters your system, it's going to go through you can call it the upper respiratory tract, but it's mainly the nasal cavity. And let's try to remember, for one thing, the nasal cavity has its own colony of bacteria, the good, the bad, and so on. And if you recall from some of the information on photobiomodulation, it helps, to release, it does this transcription factors, it does release ATP, and mostly in our case for COVID, it helps release nitric oxide into the body. And if you irradiate a colony of bacteria, that's going to happen, and nitric oxide has good outcomes. So and the olfactory area in the nasal cavity is still relevant to long COVID, so I'll touch on it a bit more. Now here's a a picture of like of a cartoon of a mitochondria. You irradiate light, you release nitric oxide, and what nitric oxide does is inhibit the replication of coronavirus of not just COVID-19, generally coronaviruses with this special envelope of spike proteins, this identity. So it applies to a from the research a wide variety of coronavirus strains. So at the nose, it could be significant in stopping the progression. And how do we know? There are some bench studies done. Basically, what this shows is, you have samples of coronavirus strain, and you deliver mock treatments. Really, there's no donation of nitric oxide. And here's treatment with SNAP, which is known to donate nitric oxide. You can see the viral counts being reduced. So this is an indication that if you can deliver nitric oxide, you're going to reduce the counts of coronaviruses. And this is what photobiomodulation seems to be able to do. Now, I talked about mitochondria being really valuable in helping to release nitric oxide and a bunch of other things that help with also immune system, which I will cover a little bit later. Now, this was an important study that showed that we have, mitochondria all over your body. It is identified by the mitochondrial DNA as opposed to nuclear DNA. It's a lot, and if you can irradiate it, you can help to release nitric oxide. So if you deliver to the nose or elsewhere in your body, this is theoretically what it's supposed to do. And here is when you do it in the nose. Now, the other thing about exposing viruses to light, it actually light of of a wide bandwidth, the spectrum covering from very short ultraviolet to pretty long to infrared, actually weakens the envelope of the coronavirus. So just exposing to light, you've probably come across exposed viruses to ultraviolet. You're going to have to you're actually going to have to kill viruses, and that is by and large pretty true. But UV may kill viruses. The red and infrared will weaken its envelope and allow your immune system to work on the viruses. So in summary, in the intranasal area, photobiomodulation helps to increase the diversity of microbiome colony, which is always a good thing when you study the effect of microbiome on your body. It releases nitric oxide from the microbiome, the colony of bacteria, and cell-free mitochondria to inhibit coronaviruses. There is the systemic effect from as I mentioned, the cell-free mitochondria all over the body. It gets circulated through your blood circulatory system, and it weakens the coronavirus's envelope, so it makes it vulnerable. So that's phase one, and when we were trying to address acute COVID-19, we have to look at the lower respiratory tract. This is also relevant because I'm going to talk about the endothelium, which is largely in various cell walls in the pulmonary system, in the circulatory system. And viruses through the ACE enzyme actually gets into from your your circulatory system through the walls, the epithelium, and into the endothelium, typically pretty quickly, and it gives with the Delta variant, it gives you symptoms of pneumonia. Now after 7 days, it starts getting worse, and the more symptoms will come out, and you're talking about more viruses entering into the endothelium. Now this has it could have a long-term effect, because it's not that the cells are going to recover overnight. When you've when your immune system has overcome your viruses. So this has relevance to long COVID. Photobiomodulation actually is pretty rich in literature and work and anecdotal reports that it helps accelerate wound healing. These are images of diabetic ulcer wounds that heal significantly quicker than if it's left unattended or help with medication. Now, it is a lot to do with the, here we say, respiratory chain or electron transport chain. Direct light into the mitochondria, it acts on the electron transport chain, and it works on transcription factors, and quite a lot of it is to do with the health of the cells and contribute to accelerated healing of damaged cells. So we said, okay, that we have taken care somewhat of the nasal area, the upper respiratory tract. Let's look at find a point where it might have a more systemic and wide spreading effect on the body when it gets into the lower respiratory tract area. So a logical place is here on the chest, above the sternal bone and right above the thymus gland, and then the lungs over here. So this is, if you want to find a point, we would place one LED module here, and it has multiple effects, and we are seeking to activate the source of T cells, which is an important component of your immune system. There's not a lot of evidence, but there's some discussions over here. So we are hypothetically going to say that we will try to irradiate the thymus gland from there. That's where your T cells emerge from as mast cells from your bone marrow. Is kind of not identified at that stage, but it gets matured. The relevant T cells get matured in the thymus gland to become T cells. So that helps the immune system. Now, I talk a lot about nitric oxide. You deliver photobiomodulation, you activate nitric oxide. And nitric oxide has been recognized. It hasn't gone through, I haven't seen any large clinical trials, but there are quite a bit of theoretical discussion, say. It's not only us, but a good number of scientists recognize that delivering nitric oxide will help not just in vasodilatation, in relaxing your blood vessels, increasing your blood circulation, but it also has the virus killing effect. And there are discussions to say, why don't use nitric oxide as a treatment? Inhale nitric oxide when you have acute COVID infection to help in your recovery. So there is relevant stuff going on in some other related studies on the use of nitric oxide. Now it gets bad, particularly in Delta. We have seen that at the peak of the pandemic, when it gets more systemic, it starts to hit the other parts of your body, and it gets into the other organs, and you have this acute extraordinary and panic response from the body to release a lot of cytokines to try to attack do a counter offensive on this invasion of the viruses. So you end up with a cytokine storm that actually could be fatal. Now, here we're talking now of elevated inflammatory cytokines that can do more harm than good, because here is the body going overboard. And the question is, does photobiomodulation has an effect on bringing down these biomarkers of, there's a running aura by your immune system. So there are some studies done. You often in the literature come across photobiomodulation helps with brain inflammation and so on. Actually, there's not a a boatload of studies being done, but there is enough to teach us that, yeah, there is enough to tell us that, okay, you haven't done a lot of clinical trials, but there is enough to show that it has potential effect. And here is a study um, done on, I think it's a bench study looking at the effect on the various markers, and particularly strong is, one of the bad indicators was IL-1. There's IL-6, there's IL-1B, and here is quite significant change when you deliver photobiomodulation on pro-inflammatory cytokines. So they were doing experiments on fibroblast cells. Now here is pretty recent. Actually, this was just published in July, and they did this human study. And I'll come back to why it's so significant that we actually have a human study. It wasn't a big study, but there was enough to show us that here is actually on COVID-19 patients, and they're able to do these blood works and measure the change in the cytokine levels. IL-1, IL-6 are the bad ones, IL-10 is the good one, and TNF alpha, they're all part of the bad group. So it actually helps to reduce the presence of these interleukins, both the good and the bad. So they say, okay, we have also reduction in the good ones. Let's study the ratio. And the prominent bad interleukins is IL-6, and they do the ratio of IL-10. And over time, compared to a placebo, the photobiomodulation effects actually reduces the ratio of the bad versus the good over 72 hours. So this is not big, but it shows, holds a lot of promise. Now let's take advantage of this, and let's try to use photobiomodulation to affect these cytokine levels, bring down inflammation. In summary, positioned here, it helps to accelerate endothelial healing and have the synthesized stem cells migrate to thymus, for the release of T cells and nitric oxide to downregulate this ARDS, acute respiratory distress syndrome, which is common in hospitalized patients. Can we control inflammatory factors? And here we are, the action of nitric oxide to inhibit pro-inflammatory cytokines. So we put this to the test on a device. We did a clinical trial on device that we already had. It was actually designed to help the immune system. Here is a report. Some of you have seen this before, but we are answering questions, particularly the primary endpoint of how do you feel today, and then put on and see how fast people recover from the symptoms, from I feel pretty sick to I feel completely well, using these statistical methods, Kaplan-Meier methods, and the proportional hazard ratio method. We have a bunch of other secondary endpoints that we look at. I will cover some of those that we have some reports. So this is a summary chart on the the Kaplan-Meier method. The red is basically a treatment. Here we are saying, looking at the probability of not recovering, over time. So you really want to see versus the blue, which is control, the trend lines significantly below the blue. And we found, yeah, it seems significant. And what we found was, when we try to make a claim, we found significance actually among those who have up to 7 days of symptoms. We did not find significance for those who have longer period of symptoms, like 8 days and beyond. And when we put them together, it wasn't very significant either. So when we say photobiomodulation delivered this way is going to help with COVID-19, acute COVID-19, we have to say that it helps those who have symptoms for up to 7 days. And these are some of those symptoms that showed significant increase as of secondary endpoints. Headache, sinus pain, think clearly with swollen glands, chest congestion. These two areas, headache and think clearly, are particularly the neurological manifestations of long COVID. So I'm glad that we have found a path to long COVID here. I'll touch on it soon. Now, what we found of significance is that the patients we had, like, we targeted 280, but at the end of the day, we are looking at 267 patients that were subjected to adverse events, monitoring and safety, and we found that those under treatments, nobody was hospitalized or died, whereas control had 4 people who were hospitalized and 1 actually passed away. So quite a bit of difference there. Now that's a good, quick rundown on what we've done. So what have we learned? What can we change now, and what do we know that could lead us to treat long COVID? I think this is going to be, well, it's important right now. COVID is becoming less of a fearful condition. So I don't hope, but I'm recognizing that this is going to last for a while. Let's see what we can do, right? The CDC has listed long COVID symptoms. There are actually 200 over long COVID symptoms, and these are the prominent one, and then the others are like derivatives of some of these. When you read about long COVID, these are the prominent ones. You're talking about tiredness or fatigue. I think this is the most prominent, and post-exertional malaise. You make some effort and you get tired very quickly. There is difficulty in breathing, shortness of breath. These are another very common symptoms. Cough, chest pain. This is tachycardia, fast beating of the heart. I highlighted this. This is basically brain fog. Difficulty in thinking, and there's headache. These are prominent, and sleep problem, dizziness when you stand, which is postural orthostatic tachycardia syndrome. You stand up and you get dizzy. Pins and needles, change in smell of taste, and depression. These are mental aspects, which I hope we can cover as we test it. And the other symptoms like diarrhea, stomach pain, joint pains, rash, changes in menstrual cycles. Now, long COVID is puzzling. So the US government is putting quite a lot of attention, particularly this administration. But, when patients go for the evaluations, when you do routine blood tests, chest X-ray, ECG, they seem normal. But the symptoms are there. And a lot of it is to do with, when I talk about fatigue, you're talking about chronic fatigue syndrome, ME, CFS. That is actually poorly understood. A lot of the medical community, and here I know in Canada, they can't even put chronic fatigue syndrome as a identified medical condition. So it's not there in the list. They call it Schedule A because no one really understands it. And I mean, perhaps someone reports chronic fatigue, You don't know what it is, whether it's a result of physiology or is it a mental or neurological issue. So it may be understood by healthcare providers, which can result in a long time before they get a diagnosis. Actually, it's just say it's just difficult to put your finger on it. Now the government is doing this big research with 1.5 billion out there for research. They are recruiting over quite a number of sites, targeting 40,000 by the end of this year. I understand they've last number was 8,500 people recruited. So it's going to be an interesting long study. But bear in mind, this study is really to gain an understanding of, there's a lot of money spent to try to gain an understanding of what this long COVID is about and do some preliminary investigation if any treatment is available to do it. So for me to say, okay, let's do a interventional study on long COVID, it may sound like a big leap, a big claim. But if I go out to get funding, I don't think it's going to be very long. People don't understand it. I don't think it's going to be that easy. But I believe photobiomodulation may have a potential basically because of its fundamental effects on the cells, which has you can go upstream and say it covers in the deficiency in the tissues, in the systems, or physiology, something at the higher level physiology. What we need to understand is long COVID is not the same as the acute COVID-19. Symptoms are quite different. As we kind of alluded to earlier, there's no real viral load. The medical treatment for, I think, Delta maybe is not so much like Paxlovid is talking about, creating more antibodies, particularly to tackle Delta. I don't think there's an answer for Omicron yet. So antibodies anyway are not effective for long COVID, but we learned some lessons. For time reasons, I didn't mention much. What we found was in our previous study, there were some small negatives, and it didn't help with fatigue and energy levels. So it was negative in somewhat, but we did it over 30 days, and this is what we found. And I suspect that if we do it longer, we might see different outcomes. These were part of our secondary endpoints. But positives would lead us to suggest that this was mental clarity and headaches were two of the secondary endpoints that we assessed. And here is where, when we say, okay, we're going to use photobiomodulation to address long COVID, the lessons we learned here is that, okay, let's steer away from trying to address fatigue for the time being until we know more. But the path is leading to a door to say, now you have significance in mental clarity, improvements, and headaches. So let's go that way. And this is where it's kind of good news to the parties sitting in this presentation. I guess a lot of us are actually very interested in looking at what's happening to the brain. Where does brain fog, mental clarity, that lies in neurological and neuropsychiatric symptoms? It is quite prominent. The prominent ones are like fatigue, and here we're talking more mental fatigue, and somewhere along the line we will have to distinguish between mental fatigue versus physical fatigue, and post-exertional malaise. So that is where I think we didn't have that as a secondary endpoint, but this is something we can look at. So memory issues, sleep disturbances, we saw improvement in sleep too, but didn't show, didn't give us a p-value of 0.05. So, but these are prominent. And when you look at the another list of cognitive functions affected in long COVID, brain fog is there. There are others like poor attention and difficulty thinking, executive functioning, problem solving, slow thoughts. Actually, I thought they all come together. I would personally would have difficulty trying to distinguish between many of these other ones, and I would be happy to call it, lump it together to call it brain fog, without being unnecessarily too technical. So, how can we treat brain fog in long COVID? So let's go back to what we found. In the 30-day assessment, the sting clearly, actually, there's pretty good significance here. Headache was another one, which I would put it as the secondary endpoint. So let's focus on the definition of brain fog. Now, there are quite a bit of research going on in trying to explain brain fog. And I remember there was in the earlier days, perhaps in 2020, people with, did an autopsy on patients who actually died in the hospitals when they were intubated in ICU. And some of them showed the traces of viruses in the brain, but I have to emphasize not a lot. And here you go, trying to explain how do they get there. I think a popular way was through the nasal cavity, going through the mucus to the cribriform plate and into the olfactory bulb, which is pretty much part of the brain. Right, that's one way. It could be through the circulatory system. Your brain receives blood, so it could go through here blood-brain barrier and into your brain because it seems quite feasible. Or through the choroid plexus. The choroid plexus it separates the cerebral spinal fluid (CSF) from the blood circulatory system. So there is some work done at Stanford. I'll touch it, more a bit later. But there, the team talks about more inflammation as a result of this. So it results in, maybe the virus got into the brain from that. But I think this actually leads to all this, leads to a triggering of an immune response. So when you talk about triggering of immune response, it leads to inflammation and more presence of cytokines. There are other explanations for long COVID. It could be a side effect of the cardiorespiratory system distress. There's failure of multi-organs that triggers every time you have this, it will trigger the immune response. There is the overactive immune system coming out of the cytokine storm with its long-lasting effect. In fact, there was also a study looked at, a review and found that virtually almost everybody who's been through intubation and intensive care actually has brain fog, almost without exception. Then there is, the inflammation of the meningeal cells, which could cause fluid leakage and activate the macrophage, causing further brain inflammation. And there is more discussion now, and I think this is very interesting, in the development of over time, your body gets set into developing an autoimmune response. It's, autoimmune is, now you're talking about a chronic condition. And the olfactory Bob is when you have deficit, a loss of smell, present in long COVID too. That is, most of these patients are identified also with brain fog. And the olfactory bulb is connected. There's the right channel to your hippocampus. Actually, the whole limbic system, including the amygdala, here you go, and the thalamus. So there is it's connecting to your brain. So you have deficits in the smell, you will most likely also experience brain fog. Here is the guys from Stanford. I think they are arguing that the choroid plexus has much to do with the inflammation in your brain, the weakening of it. So I can propose that, if you have a way of helping the lymphatic system, you might be able to help with long COVID. Here is a study. This is actually a discussion paper looking at inflammation, attributing inflammation to what similar to chemobrain, where you'll find a lot of presence of the various cytokines I mentioned, IL-1, B, IL-6, TNF, and then you activate microglia, and then you have more of this, a presence of these various other cytokines, particularly IL-6. So that attributes to brain fog. Now they were suggesting, hey, find something that you can introduce to your brain that may calm, and reduce this the presence of these biomarkers and reduce inflammation. And they said, okay, look at luteolin. Luteolin is an abstract from flavulin. Okay, I don't know. Anyway, it contributes to the yellow color in the vegetables. Flavonoids, I think. So they say, okay, introduce this. They propose use some extract from olive oil that acts as carrier and it gets to your brain. And I don't know if any study has been done, but what they're alluding to is, okay, let's find a solution. Let's find a way to bring down this the level of these cytokines in your brain to reduce brain fog and chemobrain. There are a lot of imaging studies done on what neuroinflammation looks like. Here's one on 2 subjects. I thought, normally you won't put a lot of emphasis on 2 subjects in a clinical study, but I thought this was pretty significant in its finding. It's not easy to go do big studies using MRI, and particularly here they use a particular tracer that binds to where inflammation is present in your brain. This is the tracer. I'm not going to go, here you are. I'll be at loss in trying to repeat that. But now they compared this among with against controls. They looked at older, I think they rated one of them, older and younger people, and even against multiple sclerosis patients, found that the level of the binding is pretty high among long COVID. Here's a very complicated study that requires a lot of expertise in in the genes. Talking about multimodal transcriptomics in studies and applying networks. They are related to CRISPR techniques. And what they basically saying, and you apply computer modeling as well. What it's saying is, there is information among, I think they studied like 485 samples. So the quite a lot of information in the brain. There is, it looks like dementia, cognitive impairment, and there is the biomarkers of Alzheimer's disease is there. That's why they draw parallels with dementia. And subject with APOE4 allele are quite accepted as the markers for people who are vulnerable to Alzheimer's disease, and they have reduced antiviral defense. They found this against through genetic markers. So there is similarity to dementia and Alzheimer's disease in a way. And here is another one I'm trying to explain, markers in long COVID brain that has experienced brain fog to what's present in Alzheimer's disease. Between the invasion of the virus and all this stuff that's going on, it basically lead to cognitive behavioral dysfunction and the presence of what we see in Alzheimer's disease, phosphorylated tau. So there's this additional phosphate in the tau that makes it toxic. And what happens is they have they looked at a particular protein called the ryanodine receptor, which leads to calcium ion activation, and this is overload because there's a leakage. All these are triggers from the viruses, the TGF beta. Randomized has often been associated with heart and pulmonary conditions because of the calcium leak, but it can be argued that it also affects the brain. So here's again another part that points towards, okay, another symptom seems to be that you have long COVID, you have elevated levels of phosphorylated tau in the brain, which is a marker of Alzheimer's disease. Now, the understanding of this helps us because we have been doing studies on Alzheimer's disease as well with photobiomodulation. Now, here is work pretty much done among researchers in Canada, headed by Donald Weaver at the University of Toronto. He's arguing that, look, all this stuff here, and it is particularly prominent now because you've been studying beta amyloid markers for Alzheimer's disease. It really is a wrong way to go because it's not a cause. And when Biogen came up with this drug, Aduhelm, actually is intravenous. It doesn't work. The FDA panel has rejected it, but FDA say, okay, go ahead and do under emergency use. We allow you, but you got to do it under clinical trial conditions to get more evidence. Bottom line is, November last year, a Canadian patient died from brain swelling, which was kind of recognized as a symptom from this particular drug intervention. But somebody died, and so okay, everything went to hell, and so they more or less put a stop. Anyway, doctors are not recommending it. But what they're saying is that, look, you're looking up the wrong, the wrong target in beta amyloid. Alzheimer's is an autoimmune condition. It is basically your body attacking itself. And they are they was looking at a way to activate tryptophan metabolites, which tryptophan may have the ability to reduce inflammation in your body. So they found that, okay, do this and you get, some improvements from this imaging. But that is still hypothetical. That is an argument is going on. But here's some parallels between COVID-19 and Alzheimer's. There is this.
Lou, just to give
Yep.
you a heads up, it's about 10 to the hour. If you ever want to take questions, we typically end about 1 o'clock or so. And just so you know, there is a piece of, and I'll send the medical news. There is now some thinking about Alzheimer's disease being in part an autoimmune disorder. So you're spot on with some of the new science.
Thank you. Good to know. Second
I'll send you the article.
Okay. Okay. Give me another 5 minutes, and we started late anyway, right? So here is actually I was an editor for this paper that just got literally published 2 days ago in Frontiers. So we did animal study and see can a systemic review and see if can photobiomodulation reduce neuroinflammation, and say it's really we looked at all these studies with certain inclusion criteria up to June this year. So they saw all these studies, and I said, you really have to emphasize that what you found was just animal studies. There was no human study. But good for us, and I showed this earlier, there was one particular study that related to COVID-19, and that is this particular study, the photobiomodulation. Here is pointing to the back, where the lungs are. And you actually, I won't repeat this again, it reduced the markers for inflammation. So that review paper was just too late by a month. But we have this now, which is great. So more imaging found that this atrophy in the brain too, in the cerebellum, in the hippocampal area, and the basal ganglia. So it can be widespread. And this links olfactory to the brain. So they're all kind of connected. But and we've done more studies of cells, and we did this case in concussion when we did imaging. When this retired athlete, he wasn't retired at the time, but he suffered multiple concussions and atrophied the brain. But what we found from, other than helping him, our MRI imaging showed increase in the volume of the gray matters in the particularly the hippocampal area. We did, so our gamma, they published this, did on applying 40 Hz gamma to Alzheimer's patients. This is done at UCSF. She did 8 patients over 12 weeks and found that versus control, photobiomodulation actually improved the connectivity in the default mode network area. In control, actually, they continued the progression to worse. So, so there is this, there's imaging to support what we do. And this particular study would be relevant to what you do. This looking at visual attention, you can relate it to brain fog, and talked about information. But what they found was there is suppression in alpha when they have low-grade information and brain fog. So let's see if we can do anything about this alpha. Now, when we delivered gamma to the brain, you may be familiar with this study, we elevated not just gamma, but alpha beta. So delivering gamma can help, among other things, gamma for Alzheimer's disease and cognitive impairments, as well as improving, the level of alpha. So in summary, we look at long COVID, we talk about neuroinflammation, parallel with chemo brain. So photobiomodulation potentially can affect inflammatory factors, the olfactory hippocampal disruption of cognition. We can potentially restore olfactory hippocampus. There's widespread cortical cerebral degeneration. We've seen that in our imaging in the work we've done. And then there's alpha issue. We can improve it by delivering gamma. Now we can point into these areas, olfactory, default mode, and so we get a widespread area. And this area is actually a lymphatic junction where you can help with, talking about cortical plexus and the problem with the lymphatics and blood brain. this could be a way to do it. And how do we improve it further? So we learn from evidence from previous trial. There's a related study with TBI, Alzheimer's, dementia, there's EEG, MRI, and biomarker study. We have to improve the usability of the device. Now, the weakness of the previous study we had was the lack of sham. So kind of, hold the credibility of the study somewhat. And we want to do a pilot and a pivotal this time. And we've identified a a platform that we can use to measure. This is one by Cambridge Brain Sciences that measures short-term memory among 485 subjects, and they found this. They can measure, long COVID patients have significant deficit in reasoning, verbal processing speed, with very, very significant, which is to do with brain fog overall. So I would like to thank the team that's been helping us in the study, and thank you for listening. I'm open to questions.
Well, we're going to unmute folks it takes us a minute to get them unmuted.
Okay.
And then we'll, but what it sounds like to me while we're getting folks unmuted, Lew, if I understand things, is the photobiomodulation with COVID is going to be very helpful in helping reduce some of the symptoms related to neurological and central nervous system symptoms versus the physical health ones. Like you said, the fatigue, it may not help so much with the fatigue, but with the brain fog and headaches and all that, there seems to be some real benefit.
Yeah, there are two, among all the endpoints that we're looking at, we actually didn't do too well with fatigue, and this is defined as physical fatigue. And, you're talking about post-exertional malaise and energy levels, but really we didn't cover mental fatigue. It was only one of the endpoints, but I suspect when we do, when we do the long COVID, we may have found good results.
Have you tried any other frequencies besides 40 hertz in the gamma range?
So gamma is 40. We have been experimenting with 10 hertz. Actually, we have a study that I've not talked about very much, but we are working with University of Alberta because we found that when we direct light, we've been using the 810 nanometers onto samples of microtubules in live cells. We are finding that pulse frequencies seem to matter. It actually has an effect. Now, they're around 40 hertz, and this is still ongoing. I have to say, we need more data. But 40 hertz seems to be around 39 or 40 hertz. There seems to be a switch between what goes on before, like 0 to 30 something hertz, and from 41 onwards. When we look at polymerization, the changes in the cell profile, it seems to change at that time. So 40 hertz means something. That is purely on a cellular biological level, but we're going to translate into applications into how it affects EEG. That takes a bit of time.
Okay.
Okay, and I just sent out those two articles to the listserv and to you and you too, Richard. So you have them. That they're the ones I would put out in the Science and Dailies I send out, but they just came out and they are just some of the issues you were speaking about.
Thank you.
No worries.
I have a quick question.
Yeah, Carl, please.
With regards to the PBM on the thymus area, what amount of time per treatment was typical?
So in our clinical trial, that treatment is 20 minutes. So we thought, usually when it comes to treating tissue or treating something, and most of you probably agree that 20 to 30 minutes seems to be about the time that you want something to happen and not overdoing it. So we kept it at 20 minutes.
And is that with just the 40 hertz, or you're using 40 hertz and then also doing the alpha at 10 hertz?
Right. Okay. Now, when we did that acute COVID study, there was no pulsing. Actually, it's all continuous.
Yep.
And on the chest, it was 810 nanometers, which is near infrared. Near infrared allows you to go deeper. And on the nose is 633 nanometers, is a shorter wavelength, but it's bright red and it doesn't penetrate as deep because we really want to, in the nose, we really want to concentrate on the nasal area where, just enough to get into the system for us to get the release of nitric oxide to try to attack the viruses and get into the blood circulatory system. So we weren't really trying to get too much into the brain from there. But for the long COVID study, we're going to use near infrared so that it penetrates deeper and it goes more directly to the brain. Now we could have used that again on the chest. It might be better, but this time we really want to have a sham device. We couldn't do it with the other device, which is really like the X Plus. But we want to have a sham because we get questioned. I don't know how acceptable our study is to the really critical peer scientists who say, "Oh, you don't have a sham, so you're not as credible." So we really want to be able to remove that question.
All right. Well, I think we're good. We're a little bit over the hour, but Lew, thank you so much for taking your time to be with us, and I'm sure we'll have you back down the road. You keep on doing all this great research, and we want to
Thank
keep
you.
up with everything you're doing. So we really appreciate your time today.
All right, guys. Well, thanks so much for inviting me. Thanks everybody for attending. We'll see
All
you
right.
again. All right.
Bye, everybody.